Business add-in or BADI is one type of enhancement. It is based on object-oriented programming approach. If you do not know about object-oriented programming, don't worry, I will explain the concept of object-oriented programming at a glance. Or, for better understanding about object-oriented programming, you can take my another course by title SAP ABAP Object-Oriented Programming. The main concept of object-oriented programming is a class. A class is like a blueprint. We can create an object from a class. A class has attributes. Attributes are characteristics of a class. For example, class human has attributes, name, nationality, and so on. A class also has methods. Methods are behavior of a class. For example, class human has methods speak, eat, and so on. For example, we will create class human. The class contains definition and implementation section. Attributes and methods definitions are placed in definition section, while methods implementations are placed in implementation section. And then we create object from class human with syntax create object. We can create more than one object. We call the method with syntax object name and then arrow symbol and then method name. A class can inherit another class. This concept called inheritance. A class that inherits another class is called a child class, and a class that is inherited by other classes is called superclass. Child class inherits all attributes and methods of superclass. For example, class horse inherits class animal, or class chicken inherits class animal, and so on. There is a concept in object-oriented programming that is very related to BADI. It is interface. What is interface? Interface is a class, but we cannot create an instance from an interface. Interface only contains the definition of method. The implementation of the methods are implemented in class that inherits or implements the interface. For example, class triangle implements interface shape. Class rectangle also implements interface shape. Interface shape only contains the method's definition, and the method implementations are created in the class that implements or inherits the interface. Okay, we have refreshed our knowledge about object-oriented programming. Now, we learn the concept of business add-in. Business add-in or BADI contains interface. As we have known, that interface only contains the definitions of method. And if we want to use the BADI, we must create the implementation of the BADI, and then we generate the class that inherits or implements the interface. We can see the list of existing BADI by using transaction code SE18, and then we can create implementation of BADI by using transaction code SE19. As I have said before, we can use BADI to enhance the standard program. How the BADI works in the standard program, and how we as SAP customer can implement the BADI. When SAP developers were creating SAP standard program, they found that customer may have different logic from the standard in the future. So they created a BADI and also an interface. And then in the program, they created a reference variable to the interface. And then they search for the active BADI implementation using class CL_exit handler. And then they called the method for changing the logic. When we run the program will execute the standard logic because there is no active BADI implementation. When we need to change the logic of standard program by using BADI that have been defined, we must create the implementation of the BADI and then we create the class that inherits or implements the interface. And then we write the source code for the method. And then we activate the BADI implementation. And then after that, the standard program will work as we expect. A business add-in can have more than one implementation, but however, only one can be active at any time. Besides logic enhancement or program enhancement, business add-in also can have menu enhancement and screen enhancement. We will learn more about this type of BADI enhancement directly in practice session. Okay, let's take a look at the summary. Business add-in is based on object-oriented programming approach. We can see the list of existing BADI by using transaction code SE18, and we can implement the BADI by using transaction code SE19. Class CL_exit_handler is used for searching the active BADI implementation. A business add-in can have more than one implementation, but however, only one can be active at any time. Okay, I hope you understand what we have learned in this chapter. See you again in the next chapter. Thank you. Hello and welcome to Practice 8. In this session, we will practice how to enhance SAP standard program by using BADI. Okay, let's start this session. First, we go to transaction SE18. We can use this transaction to see or to check the BADI definitions that are created by SAP developer. If we want to implement one of BADI definition, we can do that by using transaction code SE19. In the first screen, there are two options, enhancement spot and BADI name. What is the difference? The option BADI name is the old BADI definition, while enhancement spot option is the new one. The differences between them are the old BADI option contains only one BADI, but enhancement spot can contain one or more BADI definition. We see the structure of new BADI definition. One or more BADI are collected in one enhancement spot. And if we want to implement BADI using SE19, there are two options. We have to know what type of BADI is it. If we create the implementation of the old BADI by using the option of new BADI, so the implementation cannot be created, and vice versa. We see if we implement a new BADI, we have to create an enhancement implementation first, and then we also have to create the BADI implementation. In the old or classical BADI, we only have to create the BADI implementation. Okay? That the differences between the old BADI or classic BADI and the new one. And now we go to transaction MIRO. This transaction is used for creating an incoming invoice document. Two documents are generated in this transaction when we press button Save. First is invoice receipt document and the second is accounting document. For example, we have a requirement to modify the generated accounting document. So, we will search for BADI in this transaction when button Save is pressed. We fill the date field and then we input the PO number. And then we fill the amount. And then we set the text type. And then we set the transaction to debug mode. And then we press button Save. In debugging mode, we create a new breakpoint for every code that access method get underscore instance of class CL underscore exit handler, because all BADI are called using this method in standard program. And then we continue running the program. The program reached the first breakpoint, and then we see the BADI name. For this BADI name, we can check to SE18 whether this BADI is suitable for the requirement. This BADI is classical BADI, and then we see the documentation. From the documentation, we know that this BADI is not suitable. So, we continue running the program. The BADI name now is invoice update. We also can check this with transaction SE18. But we think this is not what we are looking for. We continue running the program. Note this. This BADI may be suitable for the requirement. So, we check the BADI with transaction SE18. This is a classical BADI. We check the parameters. Okay, this BADI is suitable. So, we will implement this BADI by using transaction code SE19. We go to create implementation section. We choose classic BADI and then we press button create. We fill the BADI implementation name. We fill the short text field. We go to interface tab. The class is already generated by SAP. We go to change underscore initial method, but we have to save first. We can add new logic here. For example, the requirement is to set the header text of the accounting document, and this is just an example. We take a look at the parameters first. Okay, we write the source codes. For example, we set the header text to testing accounting document. We activate the class. And then we also activate the BADI implementation. The BADI implementation is active now. Now we test the program. We go to transaction MIRO. And then we fill the required fields. And then we press button save. Document is created. And then we display the new created document with transaction code MIR4. We see the generated accounting document. We go to header of the accounting document. We see the header text is set, but the value is truncated because we did not check the length of the field. Okay, we have done this session. See you again in the next chapter. Thank you. Hello and welcome to practice 9. In this session, we will add screen in a standard program by using BADI. Okay, let's start this session. First, we go to VL03N. This transaction is for displaying the outbound delivery document. We go to header detail. For example, we have a requirement to add additional fields in this section. So, we will search, is there any BADI screen exit in this program? There are several options to search BADI. We can ask to the functional team, or we can search on Google, or we can debug this program. In this session, I will debug this program, but by different way with previous session. Okay, we go to transaction SE24. And then we display class CL underscore exit handler. And then we go to method get underscore instance. In this method, we set a breakpoint. So the program will stop running when access this method. And then we run again transaction VL03N. The program reached the first breakpoint. We check the BADI. Is it suitable for the requirement? We can check using transaction SE18. From the documentation, we know that this BADI is not suitable. We continue running the program. the program reached next breakpoint. Not this BADI, not this BADI. We press enter button. Not this BADI, not this BADI, not this BADI, maybe this BADI. We check the BADI using transaction SE18. From the documentation, we can add additional fields in delivery header. Okay, we implement this BADI. First thing we have to do is extending the standard table of delivery header. We go to transaction SE11. We open database table LIKP. This table is for storing delivery header data. We extend this table by using append structure. We name the append structure with GSD_APP01. We fill short description field. We add two fields with name ZZ field 1 and ZZ field 2, and we use existing data element. We save and activate the append structure. This may take a long time. And then we create a function group. With name Z_FGSD01. We fill the short text field. We save the function group. After that, we create a screen. We fill the short description. And then we go to the layout. And then we add the additional fields. And then we activate. In the top include, we create a data object with the same name with the additional field name. This for data transfer between screen and the program. And then we create a function module for exporting data from standard program to screen exit. We fill the short description. And then we add importing parameter. And then we write the codes for setting the value of the screen. We assign the value of importing parameter to the screen field. We activate the program. Sorry, there is an error. We fix first. And then we create a function module again for importing data from subscreen to the standard program. We fill the short description field. We add an exporting parameters. And then we write the code for exporting the value of the fields. We assign the value of screen fields to the exporting parameters. We activate the program. And then after that, we create the implementation of the BADI. We fill the implementation name field. We fill implementation short text field. The implementing class has already been created by SAP. We go to method activate tab, but we have to save first. In this method, we can set the additional screen data. First, we can set the title of the additional screen, and then we set the position of the screen, and then we set the program name that contains the screen. To know the program name, we go to the function group we have created. We double click and then we press button main program. We copy the program name and then we assign the program name. And then we set the screen number in the function group. And then the last we just set to X. We activate the program. Sorry, there is an error. We fix first. And then we activate again. And then we go to method transfer data to subscreen. This method is for transporting data from standard program to screen exit. We take a look first at function group we have created. We copy the function module name. And then we call the function module in this method. And then we set the parameters of the function modules. We activate the program. Then we go to method transfer data from subscreen. This method is for transporting data from screen exit to standard program. We take a look at the function group. We copy the function module name. And then we call the function module. And then we assign the values to the standard program. And then we activate the program. And then we activate the BADI implementation. The BADI implementation is active now. And then we test the program. We go to header detail. We see that the additional screen appear on 5th tab. And then we switch to change mode. And then we fill the additional fields. And then we save. We display again the document. We see the additional data are saved to database. But there is still need an improvement to additional fields because the fields are ready for input in display mode. I trust you can try this by yourself. We have done adding additional fields to the standard program by using BADI. See you again in the next chapter. Thank you.